All right, so today what we're going to look through is to look at a real client story for building a data platform and cloud with native AWS services. I have with me Lucy, who is the VP for Architecture and Integration at Hertz, my colleague Gautam. So we'll be covering the session together. So again, some of the things that I want to kind of highlight in the session today. I know this is a 4-level series, so we'll get into the technical details. Wanted to highlight, like, what are we covering, right? So why a data platform need for Hertz? What was the opportunity? What would a journey look like if some of you are probably on your way to building something similar or already have built? So we'll share some of that. We'll talk about how the data platform sits within the ecosystem at Hertz, especially from a digital transformation perspective. We'll dive into the cloud-native architecture, and then we'll also cover some of the gotchas or some of the key takeaways, learnings that we kind of saw throughout the course of the journey. With that, I'll hand it over to Lucy so she can at least kick it off for us, and then we'll dive into the details.
Hi. Who's heard of Hertz? Anyone? Anyone? Yeah. We turned 101 this year. 101. Talk about legacy systems, right? Yeah. So Hertz embarked upon a journey of a technical digital transformation. And it's not small, because Hertz isn't small, right? So it incorporated all of our systems. We needed to build an integrated global solution that allowed us to better manage our assets. And when I say assets, fleet systems. We needed a 360-degree of our view of our fleet. And our fleet is, I don't know, over 1.5 million vehicles, right? We also needed a 360-degree view of our customer, right? And our customer, what? Oh, I don't know, 19 million plus, and that's just on the retail side. Then we've got about, I don't know, 200,000 corporate programs that we need to manage, right? We need to also then provide all of those customers a new digital experience that is seamless, that takes all of these new systems and gives our customers a seamless new digital journey from reservation all the way through picking the car up, returning the car, payments, all the way through our financial systems. So this is a very large transformation, if you didn't already figure that out. And at the center of all of it is data, right? Data is the most important. 101 years of data. We've been building 101 years of data. So our ability with all of these new systems then give us all these new insights and all this new data, which is a re-envisioned version of our old data, right? And what we then need to be able to do is analyze it, be able to correlate it to our old data and our new data, and be able to use that to turn around our business and really be able to use the data to better enable our business to go after more new opportunities and go after the right opportunities. So all that leads to an opportunity. 101 years of data, 101 years of history. We need a modern analytical platform. All these new systems, new data, new business direction, and we'll be able to do all of that if and only if we can wrangle our data, right? We have to be able to wrangle our data, and it's immense. So what do we need to be able to do with this? What's our opportunity or challenge, right? What do we need to be able to do as Hertz with this solution? What we need to be able to do is centralize. We need to be able to centralize our data. Right now, we don't have one data warehouse. We have at least 3. and I'm sure there's some under somebody's desk somewhere that I haven't found yet. So I'm sure we have more, right? So we need to be able to centralize it. We have scale. We have lots of data. So we need to be able to scale. We need to be able to scale seamlessly and quickly. Again, data warehouse under somebody's desk isn't going to cut that. We also need to be a lower cost, right? So we need to be able to store more data with less cost, right? Which we'll be able to do. And obviously, more secure, more compliant, and all of this allows us to reduce our time to market. And if we can reduce our time to market and we can inform our business about new opportunities because we're able to analyze the data, that gives us a huge leg up, especially in our very, very competitive, more and more competitive business of rental cars. So that then gives us, much more business opportunities and new ways of going after an old business. So with that, I'm going to turn it over to Rohit to tell us how he did it.
So the key part here, we built this from ground up in 10 months. That's a pretty amazing feat. We had no footprint of AWS at Hertz when we started. Not just starting from getting an account to VPCs to figuring out what components would sit in which subnets and all of that, right? So building it from ground up in 10 months is pretty amazing. And again, there is an approach to how you get around to doing that. When we started, we knew about the first thing we wanted to at least meet was, hey, we have cross-functional reporting needs and analytic needs. People need to tie data from different business functions to be able to do that. So we went in a methodical approach. We took kind of a requirement-driven approach of figuring out what are the data and reporting requirements, what are the different sources that we're going after, and what kind of data do they produce. Some of them are event-based, real-time patterns. Some of them are batch, legacy, like Lucy talked about. But predominantly, most of this is kind of either event-based IoT data that we want to ingest in the platform and build it from a lot of patterns that you guys probably saw yesterday in sessions. So we'll cover that. We started with an architecture blueprint. So that's one of the kind of the basic starting point is to get a technical bill of material. What component are you instantiating within your data platform to be able to address all these questions around integration from different sources, what are the patterns that it needs, and so on and so forth. And in the end, making sure that my infrastructure that I'm standing up is automated. None of that should be manual at all. So it should be all single-click deploy. So Gautam will talk about some of that. We'll show a demo of how the infrastructure setup was done at Hertz. Now, kind of just rushing through some of these because we want to touch on some of the meaty slides. So another kind of key part of when we try and do a new transformation or a digital transformation, the key aspects are the engagement across business users, right? Because everyone is so set in their ways of using Teradata or Oracle, running Cognos or Tableau, what have you, that people really have a big skepticism around adopting a new technology. So the biggest, I think, the part that whenever we take a transformation journey is to understand, what are you doing to ease out some of that? So how is the adoption covered? How are you doing the change management? How are you making sure that your patterns that you're building is scalable to meet other sources as well? So some of the cloud-native solution architecture that we built is batch and streaming architecture. The platform, like Lucy said, has a ton of data, and everything is cataloged to the extent that we know what data classification it belongs to, and we can apply those security principles on it. Infrastructure and as code, so all of this is automated, as well as we are enabling some of the data science users to now harness that data and go and build some of the models. And we have over have over a dozen models that are actively running on the data platform today. So some of that we'll talk about it as well. Now, I talked about a little bit, like what's the role of a modern data platform at Hertz? So when we started this journey, there were 3 questions that we were kind of supposed to answer. One of them being, it doesn't just need to be a data lake, right? It needs to be more than a data lake, so something of an integration hub. It needs to have the ability or the capability to ingest data, process, as well as parse it to some of the downstream consumers or applications, if you will. Second being the unified reporting platform. Like I said, there's marketing, there's sales, there's operations. So all of this data needs to come together to be able to do cross-functional unified reporting and analytics. So that's the second ask. And then not just to do or limit to traditional things, but be able to scale to doing advanced analytics, machine learning, be able to do data discovery, use Athena, what have you. So enabling a bunch of data scientists using either Databricks or native Spark, if you will. So that's kind of all this is deployed on the platform. So you have an integration hub, you have a reporting and analytics platform, and you have an advanced analytics as well. We'll cover some of this in detail. I want to dive into some of the architecture and implementation patterns that we've built. So it's kind of an eye chart, a lot of components put in there, but all of this has a purpose. So let's look at it from a one-by-one perspective of what this is, again, solving, right? So you have applications that provide real-time streaming data or event-based data. You have certain CRM applications that have 19 million customer profiles, if you will, which, again, comes at a very frequent, low latency in that mind. So one of the patterns that we implemented was that we've also seen in some of the sessions yesterday was Kinesis data streams connected to Firehose, writing a payload into S3. S3 is our data lake, so there are different layers within the lake, as I call it. So there is a raw layer, which maintains the consistency, maintains the no change to the data as it originates from the source. So the data as it presents in source, as it lands, sits in the raw layer. So the pattern that you see there is a mix of Kinesis data stream coupled with Kinesis data Firehose writing to my S3. What we've done is, by looking at how frequently the streams are being written or how frequently the events are being written, we've kind of customized that to about 5 minutes or 5 megabyte payload. So it writes the file to S3 in a continuous 5 minutes pattern. We also have a capability to kind of pair that from a Kinesis data streams to Elasticsearch to be able to do some of the kind of discovery, right? So identifying where my fleet could be optimized in real time if I wanted to do that. That is done through Elasticsearch. You can display the results in Kibana, which is something that is a work in progress at this point. So we're still working on that aspect. What you see then from Kinesis to Firehose to raw, and then from raw to curated, all of this is built on a real-time fashion. So the data as it comes into S3, S3 event notification triggers Lambda. Lambda writes to SQ queue, from where all of this is orchestrated using Airflow. So if you've used Airflow as an open source orchestration, we've taken that to a next level of customizing a lot using custom Python codes, Airflow hooks, external APIs, and so on and so forth. So from the time that the data lands into raw, an S3 event notification would then trigger my Spark on EMR to then process the data to curate it. At that point, the data is available, partitioned in my curated buckets for data scientists or anyone to consume that in fairly real time. From curated to conformed is where kind of the batch, micro-batching or mini batches come into play, because I have to cater to reporting needs. People don't want their numbers to change every second or even an hour. So some of that is driven by, oh, I want my report numbers to change every hour. I want to know what's the status of fleet at a given location so I can service the customers accordingly every hour. I don't need it to change every second. So those batches are defined from curated to conformed in that order. There are certain other requirements like reservation and rental system. They want that to change every 4 hours. So we have defined that through kind of custom YAML scripts. So all the schedules are managed through YAML. So none of this is, like if you want to change the schedule, make it low latency, can all be done through a simple YAML script or YAML file. The other thing I want to also talk about is like figuring out kind of scalability for EMR was critical because we didn't have a standard throughput. We had throughput that would vary throughout the day, so we wanted to make sure that we understood the Spark parameters in detail to be able to configure the right nodes and also add auto-scaling, so it's not always running at a, kind of from a cost perspective as well. So we took care of that. So that's one of the pattern up till curated, right? We use Redshift for standard dashboards and reports. So anything that comes into conformed is already modeled the same way the data will look in Redshift. So the only difference between Redshift and conformed, if you will, is basically the number of years. So I can keep hot data in Redshift for 3 years. I can keep 7 years or plus in my S3. Any number of years for that matter. What you also see is we have an implementation of Aurora. So what we do in the entire kind of flow is auditability as well as logging. So let's say the data comes into raw. We have the first part that it hits is a data quality file format check that it does on all of that. Now, given that either is a success or a failure, all of this is logged asynchronously into my audit balance and control tables, which is a set of tables, data model behind it that is instantiated in Aurora. Now, this is done through an async IO library for Python. So what we don't want, as my data moves through different hops, I don't want a logging to be dependent, or a logging success to be dependent on my next trigger. So it's a fire and forget. I will capture my file arrival time, my details like what's the record count, what's the batch that it is associated with, fire that in a Kinesis stream that will then again micro-batch it and eventually write the payload to Aurora. So again, I'm not decoupling my architecture to a large extent. So if something were to fail, I have the ability to restart from that point. The audit balance control implementation is custom that Deloitte has, and we've implemented it at many places by now. And again, it's a cool way to say, OK, I can track if 100 events came in or 1,000 events came in last 1 hour, which is a very low number, so arbitrary. And then I can track like how many files were they associated with, what was the batch, what was the job that it processed, how many failed, how many passed, and all of that level of detail can be done through Aurora. And we have a Tableau dashboard that runs on top of that. The other pattern that I want to call out here is the implementation of DynamoDB. So there is a specific use case for Dynamo, right? I mean, it's a very low latency database. So the purpose of that is to enable fast lookups. So we have a use case at Hertz for flight status. So let's say you're making a reservation, you're landing into Las Vegas, and you have a rental car booked. Now your flight got delayed by a couple hours. The fleet operations team needs to have the ability and the transparency to move certain fleets around. That was allocated to you. I don't want to be stuck with a fleet sitting, right? So how do we do that, right? I have a reservation number which probably has your flight information if you have given it. Now at every 2 minutes, I take the reservation for the next 24 hours. I take that and I look at all the flight information that is in there. I do a real-time API call to OAG, which is flight aware, to get a response back from them. That response is then stored into DynamoDB, which does and through DynamoDB streams, we identify what changed. So let's say the flight was scheduled to land at 2 p.m. Now the status had changed to delayed landing at 3. I now know through my DynamoDB streams that the 2 to 3 now has changed, and I need to trigger that event into Kinesis that goes to the reservation and rental system so those guys can adjust the fleet. So another kind of use case of how DynamoDB is implemented with DynamoDB streams in this case. We also have a DynamoDB implementation for something called fast lookups. So like Lucy described, it's a journey. So there are a lot of legacy systems for reservations that are being cut over to new. So you have legacy codes versus new codes. Now, there is a need for you to look up those values and change from a legacy reservation to a new reservation code in real time. And these are very low latency calls that is orchestrated using MuleSoft to data platform in the DynamoDB layer. So that needs to have a very low latency response. So we're using DynamoDB for that. And all of this orchestration, like I talked about, is done through Airflow. So maybe if we can show the Airflow UI at some point today, we'll see. But there are hundreds of jobs that are from raw to curated, curated to conformed, and conformed to consumption, which is Redshift, kind of stitched together through Airflow. The other thing, as you see at the bottom, all of this is kind of tracked. So we have CloudWatch logs, we have monitoring enabled, so I can be alerted if anything were to fail at any given point in time. Or even if my auto-scaling is happening, I get an alert that, hey, my EMR is auto-scaling. So all of this is tied with proper alerting. The other thing I want to talk about from an alert point of view is a lot of places you will see lambdas, right? So what we have done from decoupling the architecture is to take it to a level where we don't want jobs to just run for the sake of it, right? So think of this as, if a file never arrived, I don't need to run anything. So I will wait to see if an event notification gets triggered by an S3 write, and then I trigger my next job, if you will. So all of this is, again, orchestrated or handled using lambdas. Lambdas are also used for alerting at various places. So if there was a failure, if there was a reject, I can handle that through a notification, through an SNS topic, through Lambda as well. So that, and then we've also done implementation for Glue. So some of the batch-related jobs, right, which are either coming or we are pulling from, let's say, legacy systems, or even from Oracle and Teradata as they are being sunsetted over a period of time. We've used Glue for those kind of workloads. Most of except for bringing the data from source into raw, everything else is pretty much orchestrated by running Spark on EMR. So I can fine-tune the implementation in any way I want. And I have more room to optimize rather than running Glue, which is kind of packaged Spark. The other thing to also note in this is an SFTP implementation. So there are certain external files, right? So think of this as Hertz buys rental cars. Hertz buys cars from manufacturers like GM, Chrysler, and others, and they create a purchase order. A purchase order gets an acknowledgement, and that gets sent back to Hertz. So what you see, Clio, is kind of another SFTP technology. So we get the files back from those manufacturers through Clio. Clio lands it into S3. From there, it's the same thing. So I have event notification, S3 event notification triggering out my next set of DAGs in Airflow that then orchestrates the load up till Redshift. From Redshift, you have Cognos and Tableau connected. So a lot of this is handled using, or the reporting is done through Tableau. So all of that is connected to Redshift, both Spectrum as well as managed tables. We also have Athena to do kind of self-service ad hoc analysis within the raw to curated layer. Because everything from conformed, you already have it in Spectrum, if not managed. But if you're doing an ad hoc query, that's managed through Athena within raw and curated. Everything is cataloged in Glue. So every file that gets written at different layers of the lake is cataloged appropriately with data classification. So tomorrow, I know if I have to manage fine-grained structures or fine-grained access, I can do that. The files are partitioned. I have some of the requirements where people have asked, like, how are you going to make sure that I don't see not everyone sees point-of-sale data, right? So we can manage that through partitions and using IAM roles and policies with that. So talked a lot. Okay, let's go to the next slide. So again, some of the patterns that I wanted to mention, and I think covered that. So we have a real-time stream ingestion pattern using Kinesis, Firehose, and S3 for all event-driven data sets. We have a real-time use case for kind of making sure that, or a real-time to batch use case. So not every consuming system can consume real-time data. So there is a need that even if I'm consuming real-time data in data platform, the downstream system can only take batch. So I micro-batch that, create a Hive table on top. An application like Glue or in Informatica, for that matter, can come read data at a required time and push that to the downstream consumers. Talked about the real-time API call to flight-aware OAG to tie reservations with the upcoming kind of flight delays, if you will, and the low latency information for anything to do with DynamoDB, both from a fast lookup as well as for flight status data, which is critical for applying to implementation. The thing I want to talk about and highlight in here is everything needs to be, as we do these kind of things, needs to be thought through from a pattern perspective. We shouldn't have, at this day and age, anything that is a point-to-point integration solving a problem, but we should always look at things that can be applied seamlessly across multitudes of these sources. So like I talked, there are 3 or 4 patterns that pretty much cater to all the data from an ingestion standpoint, from processing standpoint, and as well as from consumption standpoint. So if I go back to the previous slide, there's a couple other things, right? So when you look at the movement of data across each of the layers, talked about auditability, talked about everything being logged. There is also an element of restartability and fault tolerance, right? So if something were to fail, the platform should have the capability to reprocess from the point of failure. So what I mean by that is, like, I can generate S3, or I can generate files in S3 to mimic a particular scenario. Once the file is processed from raw, it gets moved into archive. So I have all of those files sitting in there. So tomorrow, if I know, or even a few hours later, if I know that, hey, I need to go and reprocess something again, I can move that file from archive back to my data folder. It'll trigger an event notification, and it'll, again, trigger my DAGs that will kind of move the data across different layers. So I think that covers most of it. I will hand it over to Gautam so he can talk about under the hood infrastructure design and then take you through some of the demos.
Thank you, Rohit. Good afternoon, guys. I'm between you and your lunch. I'll try to finish it off as quickly as possible. Quick show off, and how many of you work on day-to-day basis as solution architects, cloud solution architects? Okay. Cool. Very less, but let's get to the solution design, how we manage our cloud architecture, what I do on a day-to-day basis, right? So basic principles that AWS recommends: security, performance, cost optimization, automation, right? So every day, that is the cycle that I go through whenever I provide a solution or design a solution, right? I don't do slides on a day-to-day basis. I'm more into coding, right? But it takes less time to code this solution than preparing this deck. That's how I work, right? So coming to security, let's start with security, because every time, anytime, like, I think about security. So you can see all the red dots there, like buckets are encrypted. It's going through a VPC endpoint, no matter what, right? Your EMR cluster is encrypted at rest. Your Redshift is encrypted at rest, as well as in transit, right? So that's key thing. RDS and Redshift supports SSL encryption, but it's not enforced. It's very important to enforce it, right? So the AWS provides a certs. You need to import it and make sure your application communicates in a secure manner. So just because the document says it's encrypted, it's not encrypted, you need to validate it, right? So there's a parameter there that like SSL mode is fully enforced. Make sure that is activated. That would mean that end-to-end communication is secure. Otherwise, either the client is not supporting it, or you're not imported the certificate, and the transaction is not happening in a secure manner. There could be an attack in the middle, right? So that's one key learning that we had. Coming to security groups, so whether it's a Tableau, Cognos, so only those security groups are part of the Redshift security group. It's not opened on an IP address basis, it's opened on a security group basis, so that only those communications happen, right? What else is on there for security? Coming to performance. So if you can see there, we make sure all our workloads are in same AZ, and it's multi-AZ, right? We don't want data communication happening between multiple AZs. So if EMR is in AZ1, our Redshift also we prefer to be in AZ1 as the primary. RDS is also on the AZ1, so that the cross-AZ communication is not there. Right? That's another key learning or the key practices that we follow. Next slide. I think I covered everything there. So Rohit talked about patterns. So in the patterns, we sat with the data engineering team, identify the patterns. We created templates for those patterns so that we can easily replicate it. So we are talking about automation now. So day in, day out, we automate things. We don't manually do any work, right? So no least console access, everything is via code. Auto-scaling, so we use a couple of parameters here. Container pending ratio, it's a count that that's a calculation that happens between how many containers are allocated for the job and how much is still pending, right? Based on that, the EMR stack will scale up and down. There's another one is like HDFS utilization. So this is a percentage. So by default, EMR events are like pushed every 5 minutes, right? So we are taking that 5 minutes period and we are calculating the parameters and we are scaling up and down the worker nodes. Redshift stack is another pattern. We have multiple clusters, so we use these patterns to deploy multiple clusters based on the requirement. We make sure that it's not publicly accessible. Like I said, security groups very much locked down to the reporting stack, right? Aurora, again, in RDS, like we use our customized parameter groups to fine-tune the parameters that are like big list of parameters in RDS that you can customize. So we completely leverage that using CFT again. And again, the type of instances that we use is scalable. We change on the fly through CFTs again. We predominantly use Aurora for our Deloitte ABC framework. Kinesis stream. This is an approach that we took to create the whole Kinesis end-to-end ingestion pattern, wherein if we want to create a full pattern, we just have an API that would create the whole pattern. But in this demo, I'm going to show manually, manually meaning like without this API gateway, how we are going to deploy this whole pattern, the Kinesis stream, the Firos, and the S3 bucket in one click. Glue, like Rohit said, we use it as a meta store in our EMR, and that's where all the catalog happens. Okay, coming to automation deployment. So we use a cloud commit to store all our code, and Jenkins to deploy all the infrastructure as well as the application code. So we have different accounts for each environment. We can, the way we have built the whole infrastructure is like we can deploy an environment from scratch within 4 to 5 hours, including the data. That's the way we can scale. We have been scaling with Hertz. Quick demo. So in this demo, I'm not going to use Jenkins, but I will be using code pipeline, code deploy to deploy the code. Okay. This is my code sitting in my laptop. Let me see if I can bring it up. This is my parameter file, right, for S3 bucket. And you can see I made some changes, but I have not committed it. You can see the difference here. So I'm going to deploy all this Kinesis, Firos, stream, and S3 in one click. As you can see, all the infrastructure components like VPC, security, like all the security components, Redshift, RDS, everything is like via CFT. Nothing goes manually, especially in the production environment, from pre-production environment as well. Dev environment, we allow a little bit of manual work to be done because we can't deploy everything from scratch, like develop everything from scratch via CFT. Data engineers prefer to do some activities on the console, but we definitely lock them down as we go up in the environment. Okay, so I've just made all the changes. I'm going to commit it. I'm going to push this code to code commit. That went through. So let's wait for it to refresh. Meanwhile, this is the repo, the code repo. Right? And if I go back, yeah. See, just now the code commit happened. That triggered the build process. So that's going through now. So code build is putting all the codes together, and it's going to deploy momentarily. So the reason why I took only one component is the EMR Redshift will take a while to get deployed. So we are deployed already, like the Redshift EMR cluster, which takes like 15, 20 minutes to get deployed.
You have to switch it. Right, yeah. So again, in the time that the build process finishes, I think a few things that, again, from a learning perspective that I wanted to highlight, right? As you're building any of these cloud-native data platform, one thing we should always try and keep in mind is to kind of make sure that we're using more of the AWS native services to kind of enable seamless deployment. And like we said, we've done code commit, code deploy from AWS. There are certain things you want to talk about the RDS.
Yeah, so RDS, like encryption, I talked about, like make sure end-to-end communication is also taken care apart from at-rest encryption enabled. Right? Another one that learning we did was like the instance type. If you have a streamlined instance type, it helps to get the reserve instance discounts and make sure your infrastructure is cost optimized. Right? The third one is like every other day, AWS releases a lot of new features. Right? Don't hesitate to get into the documents. They leverage so many open sources. The open source documents are also very good. For example, the secret manager, it got released last year. We are using intensively. Like we thought that no one can access our database, right? So we had some issues with the application because by default, the length of the password was too big and some characters were not supported by the application. So we had to customize it. So we had to dig deep into the documentation, figure out how the Lambda works, how to manipulate the Lambda itself directly and make sure the password is what the application supports, the characteristics, right? So we had some of those.
Yeah, and also we've been working very closely with AWS SAs and PSAs to kind of help us through some of the discovery. Like we've run into several of the things. To name a few, like EMRFS sync not working at the expectation that it is. Like if you have a 5-second gap between a write and a read operation, should be okay, but sometimes it doesn't work. So I mean, when you do this, you realize that there are more things that you have to work with them to figure out or open a ticket and kind of work through those things. And like they are very helpful, timely. So leverage those relationships as well. So kind of teeing it all to the end of what are the benefits, right? What is the improvement that we've realized? So we've stood up the modern cloud-based platform to consolidate all of Hertz data in data lake for future insights generation. We've been able to run not just cross-functional reporting dashboards, but also a lot of a dozen or more of the data science use cases. Some of them, there are like fleet optimization, they have capacity substitution model, net price. So when we talk about what's the effective price at a given market and a given location, all of that is happening on the platform as well. We've also have taken care of some of the scalable compute requirements, right? So there are certain models that obviously need higher compute than some of the others. So how do you define, do you want to use RIs, do you want to use spot instances, and when do you use either of that is critical as well, so to keep cost optimized from that perspective. So if you want to switch back to demo, yes. Just show how it is successfully finished now.
Yeah, it says deployed. So all the 3 components got deployed. It's visible here, right? So, this is how we have managed to scale quickly and accommodate the developers' needs. If they want an environment fresh, we can bring it up very quickly. I think that's about it.
Yeah, I think that was probably the last slide. So given we have 10 minutes, like if anyone has any questions you want to ask, there is a mic up there. Yeah. Happy to take a few. Or we'll give you back 10 minutes because we are between this and lunch, so
Yeah.
either way.
Thank you.